Hello and welcome. My name is Partho Majumdar. In this course, we are learning how machines learn. So we start our discussion with how machines create regression models. We will take a simple regression model, that is a linear regression model, to understand the concept, and the concept will be applicable for any other type of regression models that machines learn. Before we go on to the discussion on linear regression models, just let's remind ourselves that machines can basically perform supervised learning and unsupervised learning. And in supervised learning, the machines can perform regression models and classification models. That is, machine can solve regression problems and classification problems. Now, regression problems are the problems in which the machine solves problems in which the target variable or the dependent variable is a continuous variable. So here we are. This is what we will be discussing. So our points are that this is a supervised learning model. Supervised learning model basically means that we will provide data to the machine based on which the machine will create an algorithm for itself and use that algorithm for making predictions. That is supervised learning. And regression problem basically means that we will have something like this: y is equal to some function of x, where x is the independent variable, and y is the dependent variable. So this is what the machine will try to predict for us based on the values of x what we will give to the machine. Okay, so let's get started. We will first use Excel, in which we will see the mechanics, and then we will go on to Python, where we will see how a real problem of regression is solved. So here we are in Excel. We set up a simple experiment where we want to find the hypotenuse of a right angle triangle. So what we have done is that we have taken two sides of a triangle and we have noted down the values, and then for these sides of the triangles what we have got, we have figured out what is the hypotenuse value going to be. This is a simple experiment. How this could be done is that on a piece of paper we could draw a triangle, a right angle triangle of side 4 and side 2, and then find out the hypotenuse, and again use a scale and figure out what is the length of the hypotenuse. So we do it for different values of side A and side B, and this is what we get as the hypotenuse. So now we want the machine to learn to predict the value of hypotenuse if we give him the values of two sides of a right angle triangle. So we tell the machine that there could be a linear relation between side A, side B and side C. So could you figure out the linear relation between the three sides? So the machine says fine. That means to say I have to figure out a equation something like this: y is equal to b0 plus b1 into x1 plus b2 into x2. So here x1 is the length of side 1, side A, x2 is the length of side B, and y is the length of the hypotenuse. The machine knows the values of y, x1 and x2. He has to figure out the values of b0, b1 and b2. So the machine says fine. So he sets himself up. He says I have to find out b0, b1 and b2. So this is what I have to figure out, and I will calculate according to my formula something called as he says C hat, that is my prediction of C. So I have to calculate this. So he sets himself up and he says fine. So I'm set up, but you need to give me a starting value of b0, b1 and b2. So the data scientist says okay fine, use 555 as the value of b0, b1 and b2 and try to figure it out. The machine says fine to that as well. And using these values of b0, b1 and b2, machine calculates the value of C hat. So he says C should be, according to me, b0, that is this, plus B1, that is this, into X1 plus B2 into X2. So he says, according to me, C should be this much. So he tries this formula for all the values of A and B, what is given to him, and he figures out this much. So he says that it seems that my calculations are rather far away from the values of Y what you have given me. So he says, let me find out what is the error in my calculations. So he finds out the error. He calls it as E. So the error is nothing but, so let's just color this separately. Yeah, the error is nothing but what the actual value we have provided him and what is the value calculated by the machine. So this is what is the error. So he finds it out for all the values of A and B what is provided to him. Now he says that the errors can be negative and positive because sometimes you can predict more, sometimes you can predict less. So that is not reliable. So instead, we'll just move this a little bit to create some space. Yeah. So he says, let me find the square of the error so that I have all positive terms. So he finds a square of the error, and square of the error is nothing but this squared. So he gets the square of the error for all the data points what has been provided to him. So here he says this is the square of the error. Now he says that let me have a metric by which I can know how good my estimates are. So the metric what he uses is called mean square error, or MSE. So the mean square error is nothing but sum of all the square errors divided by the total number of data points we have got. So that is nothing but the average of all the square of the errors. So the machine says I have made a rather large amount of mistake. So can I try different values of B0, B1 and B2 and see whether it becomes better? He says, okay, fine, let me try 4, 3 and 2 and find out. He sees that, oh, there is a drastic reduction in the MSE. So he feels excited. He says, let me try something else. Let me try 3, 2, 1. And he says that there is a further reduction. But the point is that the machine cannot keep on going and trying every different values of B0, B1 and B2 to figure out this. He needs to have a scientific mechanism. So one mechanism which is possible is that we can convert this to a linear programming problem and try to minimize the mean square error. So the machine does that. He sets it up as a linear programming problem. So he says, there goes. So this is my MSC, which I have to minimize. And I have to change the values of B0, B1 and B2. And let me solve it. So the machine is now calculating so that the MSC is minimum. So he finds a result. So he says that I found these values of B0, B1 and B2 and the MSC is quite low. So let me now check whether how my calculations are proper or not. So he says, give me some values of A and B and let me check how good my estimates are. So we say, let's take the value of 3 and 4. Now we know that by Pythagoras theorem, if the sides A and B is given, we can find C as the square root of A square plus B square. So we should get 5. Now let's see what the machine has got. So the machine has got, this is equal to B0 plus B1 into X1 plus B2 into X2. So the machine has got 5.3958. So that is not too bad. The machine says that it's not too bad, but maybe I could do much better. Can you suggest something else, some other formulation? So the data scientist says that maybe instead of finding a relationship between A, B and C, try to find a relationship between A square, B square and C square. The machine says that's fine. So in this case, the value of C becomes equals to square root of A square plus B square. She says this is what I can do, A square plus B square. So he says fine, give me, I can calculate x1 is equal to A square and x2 is equal to B square. That is simple for him to do. This he says this square this, and this is equal to this raised to the power 2. He copies these values across and gets all the values of A square and B square. So he has got this, and let's just, so that's neat enough. Now he says let me now calculate my new C hat. So he needs to calculate new C hat. So new C hat would be, again I need to take some values of B0, B1 and B2. So he takes a new set of B0, B1 and B2, and he says that my let me take some initial values of this. Let's start with 4, 4, 4. So he says this is got to be equal to B0, B0 plus B1 into capital X1 this time plus B2 into capital X2, that is B square. So he gets this value of this has got to be square root of this. So he says SQRT of this. So he gets some value of C hat. So he has got some value of C hat. So he calculates for all the data points and he gets these values. So here again he finds that these values are not really very close to the actual values. So he finds the error. So he finds the error. Error is nothing but actual value minus the calculated value, and he computes that for all the points. Again he says that let me take the square of the error. This is equal to this raised to the power 2, and we can find out. Now based on the square of the errors, we can calculate the mean square error. So I just copy this and put it here. So this is nothing but the mean of these values. So he finds the mean square error. Now he says that let me try to minimize this mean square error. So and see whether I get a better result or not. So he again sets it up as a linear programming problem. So where he says that let me minimize this by changing the values of this set of B0, B1 and B2. And he tries to solve this. Now he's solving it. So optimizing using linear programming is one mechanism. There are other mechanisms like gradient descent, and there are many more other mechanisms which we will discuss. But essentially this is the mechanism. He sets it up as a mathematical model and then tries to optimize the result. And after he gets the optimum result, he says, let's see how good the predictions are. So now he has got some values of B0, B1 and B2. And let's see how good the prediction is going to be using these values. So we need to first calculate a square. This is a square and this is b square. So this will be equal to 3 to the power 2 and this will be equal to 4 to the power 2. And he will find b0 into a square, b0 plus b1 into a square plus b2 into b square. And then we have to square root that value. So here we go. This is b0 plus b1 into a square plus b2 into b square and the square root of the whole thing. So you see that now his prediction is much better. He gets 4.99 something, whereas the actual value should be 5. So this is much better prediction. So this model seems to be much better. So essentially what we have seen is that the machine can solve a regression problem like this by setting it up as a equation what he has to solve and then trying to find the parameters. So we have seen how the machine creates a linear regression model. Next, let us use some real data and create a linear regression model for a real problem using Python programming.